Hi, I'm Brian Che, Chief Strategy Officer at Huawei, and welcome to Building the Future of Pervasive, Ubiquitous, Collaborative Intelligence with ARM and Open Source. So a lot of us have been stuck at home pretty much this whole past year, and this has been one of the big driving factors that's really accelerated the adoption of digital technologies into everything that we've been doing. And I think, as we start to experience this digital transformation around us, taking a look at the Internet of Things as well as AI capabilities has been one of the most obvious ways that all these new digital technologies are impacting us, especially at home, and also in all of our environments around us. If you look at the growth of devices, this has been on a pretty steady state growth from 2015 up until last year. But starting from 2019 up through 2025, most people expect an explosive growth in the number of devices that people are going to be connecting to all around their environments and all around the world. And it's not just the physical devices that people are going to be interacting with. There's going to be a whole new range of digital services running in the cloud and in the edge environments around that are connecting and powering all these things around them. And so as we think about how do we get to this new world where we have an explosive growth in the number of devices that people are interacting with, when we have an explosive growth in the number of network connections dealing with all these different things, as well as in the computing power required to power all these things, where is all this leading to? So I'd like to take a few minutes during this keynote just to share with you a little bit in terms of how we at Huawei envision this future and the possibilities that it's going to enable, as well as how we are starting to go about in building this in an open way with the rest of the industry. So I'd first like to start just with a brief introduction about what this future might look like. And so I'd like to share with you this brief video just to go over a little bit in terms of what we think this future might look like as we go into this new world. So I hope you all agree with me that we really believe that using technology to be able to improve our lives, especially in important scenarios like health, is something that's really critical and really valuable that we can all usher in with this new wave of technologies. The problem, though, is that even with the most state-of-the-art things we have around our smartphones, with our different smart devices around our homes, with our environments, with all the AI-powered cloud services, there's still a lot of very fundamental challenges that we have in our industry today that prevent, something like the scenario that we showed with Philip in the example I just showed to you. What is it that is preventing us from being able to have, such a smart home, connected to such a range of smart health services that really improve our lives from a day-to-day standpoint? I think there's a few key challenges that we're all facing from a technology standpoint. First off, we're all facing different technology silos as we work together. When you think about the range of things that have to cooperate within an environment like that, from our phones to different, smart speakers, to different cameras, to different cloud services and health services that we interact with, to different, networking routers and different devices. These are all typically from different vendors, they're from different ecosystems, and they don't work together very well. Even when they are from the same vendors, it's often very hard to be able to unify them across these very, very different and complicated scenarios where we have sort of emergent activities that work across every single one of them. Another big challenge is that not all the different devices have the same size ecosystems because they have different adoption rates. Everyone, of course, pretty much has a smartphone these days. But how many of you have a smart camera system, deployed pervasively around your home? Or how many of you have smart wearables, whether it's a watch or some other fitness device? And when you think about, having to write individual applications for all these different devices, these have different market sizes, and so there's very different developer ecosystems that emerge from all of these. And so we see that these are very fragmented technologies silos, that they're very fragmented developer ecosystems. And it's not just from a device standpoint, it's also when we think about from a cloud and from an AI standpoint as well. For example, when you think about all the range of intelligent capabilities that have to power both the devices as well as the cloud services in our homes, as well as in the data centers that are backing these, it's extremely expensive and extremely energy intensive to be able to power this range of capabilities. And so, right now, there's not that many enterprises in the world that can start to develop and to be able to train and to be able to, provide all the things that are necessary to enable the intelligent interactions that we just saw. Simultaneously, when you think about the different form factors that we have to put all these AI capabilities into, whether it's a fitness device or into a laptop or into a phone or in the cloud itself, this is a huge range of different computing power that we have to run intelligent capabilities across. And so this is a big challenge. How do we scale AI up and how do we scale AI down in order to be able to run across all these different environments and all these different form factors? It's a very heterogeneous environment that we have to run across. And finally, and perhaps most importantly, we have to think about both the communication between all these devices, as well as the sensitivity of the data between these devices that we want to transfer. And when we're dealing with critical health information across fitness devices, around health wearables, around sensors in our home, we don't want to be constantly streaming all this data back and forth into the cloud. This is both from a data privacy standpoint and just from a pure architecture and efficiency standpoint. To be able to transfer all that data across all these devices into the cloud is extremely difficult and also extremely privacy invasive. And so how do we start to build a fundamentally better approach to be able to coordinate and support these diverse ecosystems, this heterogeneous environment, as well as a lot of these data issues? In order to address these, we think that there's a few fundamental things that we need to change in the overall industry. First off, we need a brand new set of lightweight infrastructure, from our devices all the way to the cloud backend that is able to scale our AI up and our AI down into all these different environments. We also need a new way to be able to achieve interoperability across our devices, as well as between the devices and the cloud and the edge ecosystem. We also need to be able to enable developers to be able to write applications that easily span across all these different environments, from different form factors of different devices, all the way out to different cloud and AI systems running in the cloud and in the edge. And this is a huge, huge range of different technologies that we have to work across. So in order to power that, we really believe that open source is really the best and probably the only way to be able to drive the innovation and the open ecosystem that is necessary in order to bring all these things to life. Using the power of open source, we can start to create a unified ecosystem that spans across all these different devices and all these different environments. And so what we want to do is to be able to enable this new kind of environment where developers can start to think about, how do I start to write to these different scenarios? For example, maybe a healthcare scenario where I can really improve people's environments and improve people's lives, and I can work across all the range of devices they may interact with and all the ranges of cloud services that they may need to work across. And using that open source ecosystem, how do I start to then take advantage of all the different hardware platforms and data systems, whether it's ARM architectures or data security and privacy between the cloud and the different devices? And so this is the kind of transformation that we really think has to happen in the industry as we start to bring these kinds of scenarios to life. And so this is very much what we've been focused at Huawei in terms of how do we start to deliver these capabilities. And we really see this as building out, sort of twin capabilities. First, we need to focus on how do we start to create a new kind of distributed device ecosystem that can work across all of these ranges of different scenarios and environments that people interact with, and all the different hardware form factors they'll interact with from a device standpoint. Simultaneously, we also need to support a huge range of heterogeneous computing environments, especially as we power all the AI services that are going to interact with this intelligent world. And connecting these two environments are going to be all the smart connections that people live with. And this could be everything from your broadband in your home all the way to your 5G connections out into your environment. But all of these need to be tied together with smart connections. And two of the most fundamental things are powering these in terms of how we are building this out at Huawei are two new operating systems that we have been building out in open source. So from a distributed device standpoint, we have a new open source operating system called Open Harmony, which is focused on distributed IoT devices. And then for the heterogeneous computing environments in the cloud data centers, we have our Open Euler Linux operating system. But this is not just any old Linux operating system. This is highly focused on how do we bring the range of AI capabilities out to heterogeneous computing across AI, platforms running in the edge, in the cloud, and around heterogeneous hardware platforms. And so what I want to do during the rest of this talk is just explain to you a little bit more, both what we're doing from an Open Harmony standpoint, as well as what we're doing from an Open Euler standpoint, and then tie it all together for you. Let me go ahead and start off first from an Open Harmony standpoint. So as I mentioned before, Open Harmony is our distributed operating system focused on how do we bring a new kind of user experience around different consumer devices. And in order to bring this consumer device ecosystem to market, we really think that there's a few key things we need to solve from an industry standpoint. First off, just think about the range of different devices that you have to interact with from a consumer device standpoint. You've got your smartphones, you've got cameras, you've got speakers, you've got wearables, and so on. All these things are coming across different form factors. They're probably coming from different vendors and different technologies. And they all need to work together from a unified ecosystem standpoint if we want to start to enable them to be able to cooperate together to enable very broad-based experiences across these different devices. That means you want to have your smartphones interact with your smart devices so that they can share health information. They need to be able to interact with your cameras and so that you can interact with them, or your network connections so you can start to share data as you see fit. That means that all of this needs to be built in an open source way, but also with open governance so that we can have a broad-based ecosystem where everyone can come together on equal footing to be able to build this together. And we also have a common set of standards and open technologies that everyone can build upon so that all devices, no matter who it's from and no matter what it looks like, can start to cooperate together. Based on this foundation, we can bring forth a new kind of architecture for how do we start to create a different kind of operating system, which is really distributed across a wide range of different devices. So this is where our Open Harmony operating system comes in. And the key thing about Open Harmony is that this is really a distributed operating system that runs across multiple physical devices. So let me show you how we start to build out the Open Harmony architecture. The first thing about Open Harmony is that we focus on distributed design so that we have three fundamentally different distributed capabilities. We focus on distributing task scheduling, data management, and a resource pool. And remember, this is distributed across different physical devices. So I could be running across a smartphone, across a watch, across a smart screen, for example. In today's scenario, the way that we would build out interactions across these is we would have one operating system running on a watch, one operating system running on a phone, one operating system running on a smart screen, and we'd probably have some kind of cloud-based interaction that would tie all these things together. And that's very inefficient because even though these three devices are all sitting physically in the same room together, they all have to be tied together through the cloud in terms of how they interact. And this is very inefficient. So, and instead, what Open Harmony allows us to do is it allows us to build a distributed mesh network across all these different devices and to run the scheduling, the data management, and the resource pool dynamically across these different physical devices as if they were one physical device, and to aggregate them together into a virtual device. And this is a key difference between Open Harmony and other operating systems in that it allows us to create this distributed architecture across multiple physical devices. But it's not just efficient to be able to run these capabilities in a distributed mesh network across devices. It's also much more secure from a privacy standpoint, because if you have to be able to share all this data continuously across the cloud just to be able to have things interact, now this means that you're sharing very, very sensitive data constantly streaming to the cloud, and that creates a very strong point of failure, both from a privacy standpoint in terms of an attack point, but also just in terms of how are all these different cloud services going to interact together, especially when you're dealing with multiple vendors with all your different devices. So instead, we think it's a much better approach that you don't even have to share your data into the cloud in the first place. Instead, all your data can remain local to your devices, and this allows everything just to be able to work together across your devices and protect your security and your privacy in a much better way. We think this approach is also much better for application developers because now application developers can start to create what we call these super devices. And they can start really imagining, what if I could have, a camera on a smart camera, and my interaction on a phone, and my speakers from my smart speakers, and all these things can be aggregated together to create a super device because I just have distributed capabilities across all these things timed together. In order to support that, Open Harmony also supports a wide range of different hardware types. So for example, one of the things that we enable is supporting different operating system kernels, because we know we have to work from very, very small form factors all the way up to much more capable devices. So we'll support different kernels such as the Linux kernel or Zephyr or even LightOS. And so we need to be able to support a wide range of different devices and bring them all together as one virtual device. And this means that application developers only have to target these aggregated devices once, instead of writing one application from each device and then tying this all together and dealing with fragmented ecosystems. And this is also super beneficial for users as they experience these capabilities, because now they can start to experience holistic scenarios. Now, I'm just dealing with the health scenario in my home, or I'm dealing with an exercise scenario outdoors, or I'm dealing with a work environment, and how do I collaborate with my office mates from a virtual environment standpoint. All of these experiences are tied together around all the different devices I interact with, versus I have to think about how do I work with my watch, how do I work with my phone, how do I work with my laptop, then I have to stitch them all together myself. So this is a much better user experience because they can experience all their devices coming together in a very holistic manner. And so basically, we believe that this is fundamentally a much better approach in terms of how do we work with consumers, because we can give them this much better unified experience around how they work with all the different devices that they have around them. This is much better for all the different device manufacturers, because now they can all tap into a unified open ecosystem where all their devices are not just working by themselves, but they can collaborate with everything else out there. And this is also perhaps, really, really the best for content creators, because now you can start thinking about how do I create these different scenarios that work across all these different devices and just aggregate them into these super devices that support different content scenarios, whether it's healthcare, whether it's fitness, or anything else that we want to dream up. And so we believe that this is really where the future of devices are going and how we can start to tie things together. And so if we come back to that scenario that I was showing in terms of the healthcare scenario, now we can start to take all of those different devices. So for example, a smartphone, a smart camera, smart speaker, your smart doorbell, and your different networking gear and so on. And we can now start to tie them together. In order to do this, the first thing that we would do is we would start to tie these all together into this virtual mesh network so that they all become aggregated into a super device. Now, as part of aggregating them together, we elect one coordinator, which is basically going to be responsible for how do we assign, all those capabilities, such as distributed task scheduling or distributed resource management. And that one device will be responsible in this scenario in terms of managing it, but it can change dynamically based on the environment that you go into. And similarly, we can also train using intelligent capabilities across these different devices. So now your coordinator knows how to be able to respond and interact to your environment based on what's happening, but keeping all the data local to these devices. And so by aggregating all these different devices into distributed resource pools and a super device, this is a way that we can start to really help the devices work together. But that's just from a device standpoint. As I mentioned before, we also need to highly optimize what happens from a cloud and from an AI standpoint. And perhaps one of the biggest challenges as we think about how do we start to provide the intelligent capabilities in the cloud is that AI training provides two very fundamental capabilities. It trains all the intelligent capabilities that goes into the devices that we just talked about. And it also provides a lot of AI cloud-based services that interact with everything that we do to be able to tie everything together into a very rich ecosystem. The problem, though, is that AI is a very expensive set of capabilities. It's expensive both in terms of from a monetary standpoint, in terms of how do you run it, and it's also perhaps even more expensive in terms of the energy consumption that it takes. Here, this is what happens from an energy consumption in a typical cloud data center and where all the capabilities are going as they start taking a look at more AI-focused and data-focused cloud workloads. We can see that the general CPU is heavily, heavily taxed as we start to run these different workloads. In the meantime, a lot of cloud data centers are adding more and more specialized resources, such as NPUs or GPUs, in order to be to run these AI workloads. But the amount of these processors is still relatively few compared to general purpose CPUs, even though they're highly more efficient in terms of how do they run these AI workloads. So we believe that the best way to optimize these cloud data centers going forward, both to achieve a peak performance, but also to be able to achieve peak energy savings, is to optimize the general purpose CPU to be much more energy efficient and processing efficient. And so this is where ARM CPUs especially come into their own in the cloud data center, because as we all know, ARM CPUs are much more energy efficient than a lot of other capabilities, and this starts to bring down the general purpose CPU capability. Simultaneously, as we start taking a look at all these GPUs and NPUs, which are highly optimized for machine learning training and inference workloads, now we can drive a lot of those specialized workloads into these NPUs, and now we can achieve the best combination of performance, drive them into more efficient NPUs and ARM CPUs, and also we can start to support heterogeneous architectures, which gives us much better energy efficiency. But if we really want to start going after these architectures, we need to start supporting them from an overall data center standpoint. And so this is where our Open Euler operating system is really focused on how do we start to bring these highly optimized AI workloads into the cloud data centers. And there's a few key innovations that we've put into Open Euler that I want to focus on. The first is that Open Euler is highly optimized to be able to support all these different architectures from a hardware standpoint. And so we focus not just on traditional x86 processors from a Linux architecture standpoint, but we really treat every single hardware platform as a first-class hardware capability into Open Euler. So how do we focus very well on ARM processors from a CPU standpoint, and also add first-class support for NPUs and GPUs? And this is all because we want to optimize Open Euler to take advantage of these new hardware architectures that are emerging between the cloud and the edge, which are highly heterogeneous from a processor standpoint, but which need to support a wide range of applications. And so by supporting all these different applications across this heterogeneous hardware architecture, Open Euler is really equipped to be able to bring this new wave of computing platforms into a highly optimized way to support intelligent workloads. Now, in order to be able to support these AI workloads, it's not enough just to be able to support these different hardware platforms, such as ARM and such as different NPUs. We also need to look at what are the capabilities within the operating system itself in order to be able to optimize for bringing AI into these different environments. Now, one of the things that becomes critical is that it's not just massive cloud data centers that are going to be running these AI workloads of the future. These are going to be also split across heterogeneous architectures. And so, for example, we've got to deal with cloud data centers. We've also got to deal with a lot of these emerging edge data centers that are spread out all across our environments around us. So in order to be able to support that, we need to be able to also take the operating system and to be able to run them in all these different environments, supporting just the sets of capabilities that are required, whether we're going onto a very large public cloud, whether we're going into private clouds, whether we're going to edge capabilities, and so on. And so one of the key capabilities that's been built into OpenOiler is that it is very flexible in terms of how do we compose OpenOiler to be able to deploy into different environments. So fundamental to the OpenOiler set of tools and the architecture is that it is very modular, and it enables us to be able to select just the components that you need to deploy into a very lightweight architecture in the edge, for example, or into a very rich environment running in a full-fledged public cloud. And this allows OpenOiler to be able to support with one operating system platform across all the different hardware architectures, as well as the different hardware processors that you're going to be running across. And so when we take a look at how do we support these heterogeneous architectures that are going to be powering these intelligent capabilities, OpenOiler is designed especially to be able to support the hardware diversity that you're going to be running to power all these intelligent capabilities in the back end. Another key innovation that we've been putting into OpenOiler is how do we start to make OpenOiler lightweight enough so that the operating system can scale up and scale down to these different environments. Because it's not enough just to be able to compose different features that are going to be running in one environment or another. We need to make every single feature that is running across these environments as lightweight as possible so that we can achieve a uniform standard in terms of what are the applications that are able to run across all these different environments from cloud to edge. And so, of course, two of the most important environments that people take a look at when they run across cloud and edge platforms are containers and virtualized environments. And so when you take a look at a lot of the traditional technologies that people are using for containers and virtualization, for example, Docker or QEMU, these are relatively heavyweight in terms of how do we run them across different environments. And one of the things that we have highly optimized into our OpenOiler operating system is that we have created new runtime environments which are extremely lightweight and which can run in a very, very small footprint from cloud to edge. And so, for example, we have our ISULA environment, which is a highly minimal footprint from a container engine standpoint. And so we can provide a unified container environment that goes from your cloud to edge with no changes because it is running in a very, very small footprint. Similarly, from a virtualization standpoint, for your more traditional scale-up applications, we have our StratoVirt virtualization runtime. And this is also highly optimized to run in a minimal footprint so that we can bring your virtualized applications uniformly from the cloud to the edge. And so this allows us to bring those AI applications across all these different environments. First from a different set of processors, next to a different set of architectures, because we can compose the operating system differently. And finally, within the OpenOiler operating system itself, we've made the components as lightweight as possible so that we can scale across all these environments to be able to run your AI applications. Now, one more thing that we've been focused on from an OpenOiler and especially from an ARM ecosystem standpoint with OpenOiler is how do we start to enable the overall ecosystem across this, both from an application and availability standpoint, but also from a security standpoint. And one of the most important things that is necessary is when you work across all these different open source architectures and applications, is that you need to enable continuous testing and building across all these different environments. And this is something that pretty much every single open source project has. They all have their x86 based CI systems, which is all focused on how do we bring all these applications and test them across x86 architectures, because this is the set of platforms and the set of tools that we've been living with for these last couple decades. The problem, though, is that even though this set of capabilities is very important, and x86 will be with us for a very long time, we haven't had these similar sets of capabilities from an ARM standpoint, for nearly as long and nearly in as mature a manner. And so one of the key capabilities that we've also built at Huawei is this tool set we call Compass CI, which is really focused on how do we enable a CI system for ARM across the open source ecosystem. And so what we have done is that we have enabled Compass CI to be able to come and build the same set of capabilities from a CI standpoint for all the different open source projects onto an ARM-based ecosystem. And simultaneously, we have been working with all the top open source projects and ecosystems so that they incorporate this into their standard build systems, so that as we start to build these open source projects, we automatically get ARM-based builds along with our x86-based builds. And this highly optimizes us for this heterogeneous world that I've been talking about. And this is also super important for making sure that these ARM-based platforms are secure and always get the latest and greatest features as well. And so by bringing this set of capabilities, this is how we start to enable and support this heterogeneous platform as we take a look at from a cloud computing standpoint and from a data center standpoint, enabling this rich open source ecosystem in the back end. So now just to come back and tie all these things together, we've been focused, as I mentioned, on really building this future world where we can start to tie everything together. And for us, it's really important to do this in open source. And this is why, on the device standpoint, we've been focusing on a new distributed operating system that can aggregate all your devices together with open harmony. Similarly, on the backend in your cloud system, we really need a new kind of operating system that works across heterogeneous computing and that ties everything together in a very lightweight manner. And this is Open Euler. And by combining the power of open source around all these different environments, from distributed devices to heterogeneous computing, this is how we think we can start to build this future of pervasive, ubiquitous, collaborative intelligence together. And so because we're doing all this in open source, we would welcome you to come and participate with us and to learn more about what we're doing. You can do this by coming to visit our booth here at the Linaro event, and we welcome you to come meet our experts and to talk with us, as well as to join our open source projects. So thank you very much, and we look forward to working with you and collaborating with you on these in the future.